Okay, so greetings. Welcome to Eureka Math Squared. We're hanging out with grade 6, module 5, lesson 2, all about the area of right triangles. So again, it's all about area, and area is measured in squares like this little bugger here. And so what you do is you find out how many squares fill up a particular shape. The problem is this thing is a triangle, so filling it with squares gets a little interesting with this little triangular guy here, this diagonal line segment. So here's the deal with area of right triangles, right? The little trick, here it comes, right? Triangles, watch this, are actually half of a rectangle. There's the secret. Watch. Watch this, ready? So there's a triangle, but if you use your imagination a little bit and you take this guy and you copy him and flip him over a little bit, and you wind up with two of them, right? Two identical triangles. There they are, right? So here's the first one, and here's the second one, or the original one, right? And they're exactly the same size. So check out what I formed here. I actually created a rectangle. There it is. Now the area of a rectangle is just take the length and multiply it by the width, right? Maybe that's the length, maybe that's the width, or maybe that's the length and that one is the width. It doesn't matter. You would then multiply the two values. You would take the 11 and you'd multiply it by the 4 and you'd get 44. Now here's the thing. That original triangle is one half of that rectangle, right? Because we made two of these things, right? So all you have to do now is take that 44 that you have here, right, and divide it by 2. So take your 44, you divide it by your 2, and your area now is 22 centimeters squared, right? Always these guys, right? Squared, because again, we're stacking squares. We're measuring using squares. That's how you measure space. Okay, so what do we know? Well, we can take all of this information, this one rectangle, take the area of the rectangle, divide it by 2, and we can create one formula. And it looks like this. Take the area, right? And I want one half of that rectangle, right? This big old rectangle, here it is. There's that rectangle. But we don't use length and width. Instead, we use a base and we use a height. Okay, so this guy gives me the area. If I multiply these two, that's like the length and the width. That gives me the area of the rectangle. And then the 1/2 is like dividing it by 2, taking half of, right, half of the rectangle. And that gives me my area. So I'm running out of space here, so let me just delete some of this, right? And we'll work this next one. And I think after that, anybody could be pretty good with this. Okay, so this guy's a little bit slanted, but so what? It doesn't matter. I have a right triangle. This is the corner of a rectangle. So if I were to redraw or draw the same rectangle over here, and I create, triangle over here, I create a rectangle out of two of those triangles. There it is. So the dimensions of the rectangle are 9 and 7.3. Ordinarily, I would just multiply those, right, to get my area. But I just want this triangle, which is half the size. So my formula is take 1/2 of the length times the width, or in this case, base times height. So only length times width is used for a rectangle. As soon as we switch over to triangles and parallelograms and things, we use a base and we have a height, but they are the same dimensions, right? Let's say this guy is the base. Let's say this guy is the height. Notice that they do form right angles, right? Because there they are. They are called perpendicular. They're perpendicular to one another. So they create the two sides of what could be a rectangle. Okay, so now all I have to do is plug things in. So I'm a big fan of parentheses, so I have the 1/2, and I can put the 9 there, let's say, and the 7.3 in here. It doesn't matter. I can change the order all I want. And now all I have to do is just multiply a little bit. So let me just multiply these two first. Why not? Because if I'm just taking half of 9, right? Half of 9 is really 4.5, right? Half of 9. And then what's left is the 7.3. So I can just take my 7.3 off on this side, multiply it by the 4.5, and I'll have my answer. So 5 times 3 is 15. 5 times 7 is 35, plus 1 is 36. Done with that guy. I'm done with this guy. I'm done with this guy. 4 times 3 is 12. 4 times 7 is 28, right? Plus 1, 29. Getting a little sloppy, sorry. There's a 5, there's an 8, there's a 12, carry a 1, there's a 3. And since I have tenths times tenths, that gives me hundredths. Or I have 2 digits after my decimal, so I have 2 digits after my decimal. I wind up with an area of 32.85 squares that are measured in inches. So inches squared, right? Don't forget that guy because we're measuring with squares, right? Little squares, we're stacking those buggers. So in other words, 32.85 squares would fit into this triangle, right? That are inches in dimension. There you go. All right, so that's the deal, folks. Hope you enjoyed that. So long. Take care. Bye-bye.